Hi YouTubers, today I'm going to talk about batteries and work on to solar panels. Now this is my understanding of batteries and solar panels, so you cannot guarantee that this video is correct to my knowledge, but this is how I understand it. And I'm going to start off with batteries because then it makes it a little bit easier to understand what I'm talking about when I talk about solar panels. Now, you can connect batteries in series and you can connect them in parallel. When you connect them in series, the current remains the same through the batteries, but the voltage you add together. So, for example, in this case here, I've got a 6 volt battery connected in series with another 6 volt battery, and what you do, the current of both batteries, because they're both the same, is 1 amp, so the current in the circuit is 1 amp, but you add the voltages together. So with these two you end up with 12 volt. This is really good. Now then, this is providing you have two batteries that are fully charged, same make, same model, same type, purchased at the same time, and you charge them together and they discharge together. Now then, this is why you keep batteries, don't mix and match batteries. Now, if for example this battery here fails, the lamp will probably glow dim. So if that's a bad battery and that's a good battery, it may not be apparent. The polarity changes on this battery. So if this battery is faulty, it's not giving anything out, so the voltage becomes 0. And because this battery is say fully charged, the positive of this battery puts positive on the battery. So instantly you can see the polarity has changed on this faulty battery. So if the batteries are not balanced, you'll get the first battery will be reversed polarity trying to be charged via this battery, because this is the earth here through the load, so that is 0. This is alright 0 here. This battery is positive, so this battery will end up with a positive there and a negative there. So this battery could explode if this is a high current battery, because you will reverse polarising it. It may be leaking inside, it may... The other thing is, you could boil this. If it's a lead acid battery and you're still trying to pass current through it to the load, and it's not getting to the load, and it's trying to charge this battery this way, this could cause it to gas. Now, from memory, there's ways of overcoming this, and you don't want gas build-up in a boat or in a submarine or anything like that when you've got banks of batteries. So what you can do for safety, or what has been done in the past, you put a diode across the battery like that, and it means if this battery goes open circuit or high resistance, the current will flow through the diode to the load and be diverted from the battery, so you don't get this reverse charge effect from the second battery. This is done on submarines and things like that, because if you get a faulty battery go down in the bank, you don't want it giving off gas, which is explosive. And it's the same with a boat. You know, you put diodes across them, and in fact sometimes there's a diode across there as well. The diodes only let the power flow in one direction. So I hope that makes sense. So you have to have the batteries the same type, the same voltage, the the same current rating, purchased at the same time, and if they're rechargeable, you charge them together. And as I say, if you've got two batteries in series, the voltage adds together, the current remains the same. Now then, moving on to parallel. With parallel batteries, the voltage remains the same if you're using the same batteries, which you should do, but you add the current together. So two 12 volt batteries across the load still gives you 12 volt, and you add the currents together. But again, you shouldn't mix and match batteries. They should be purchased at the same time, the same current rating, same voltage, same model and everything, and you charge and discharge them as a pair. And the reason for that is similar idea to this. You can get problems. If this battery is faulty and it's flat or leaking electrically, this battery will try and charge that battery. So the power of this one will flow into the battery and it'll very quickly discharge this battery as well as itself. Similar, when you try and charge the battery, you put on your charger, it will never reach full capacity on the good battery, because as fast as it's charging, this one is leaking the power away and maybe just causing it into gas, may just be bubbling. So you always keep the batteries the same, and with age change them together. When you replace a battery, you have to change both of them at the same time. Similar with a series circuit, if one of them's failed, you change both, because it's weakened the good battery in both cases. You can't use the diodes in this situation because it's parallel. And that's really it with parallel and series. The only thing I would mention is I've heard of people trying to start a car or a motorhome with a leisure battery and a car battery connected together to give more power. Right, a car battery is designed to give massive amount of current for very few period in time, like half a minute maximum. The plates inside are very thick and all the connectors to the plates are heavy duty. So a car battery will give loads of current for a very short period of time. A leisure battery is designed to give a small amount of current over a long period of time. The plates inside are not as thick and the electrical terminals as an engine starting battery. And if you try and start a car, it can actually warp the plates inside the leisure battery. It can actually blow the links to the cells inside the leisure battery. It will do it in. And the opposite, if you use a car battery as a leisure battery, you get, I don't know what it's called, phosphate to the plates. You're not drawing enough current and the plates get crystals growing on them, and it will do the car battery in as well, using it as a leisure battery. It's not designed for small amounts of current over long periods of time. The plates build up carbon or corrode or something happens to them, and the area exposed to the chemicals is reduced because of build up of crystals or something like that. Now then, this is something I learnt from my father. you cannot charge a car battery, liquid battery, on pure DC. You need some way of shaking the bubbles off the plates. Now, when you're driving along in your car, the process of the road vibration shake the plates, and that causes a bubble to come off the plates and go to the top in the liquid. So you always get a better charge when you're driving and the engine's running than actually using a battery charger at home. Now, if you've ever put a battery on charge in your shed and you listen to it, it will buzz. And that's because the design of a battery charger for a car battery, liquid one, is only halfway rectification, and it's going buzz, and that's shaking the bubbles off the plates. Now, if you look at the amp meter gauge when you're charging a battery, if you shake it and get more bubbles off the plate, you'll notice the current increases. And this is because you've shook the bubbles off the plates, the chemical is actually touching the metal, and you're getting the chemical reaction. When the bubbles build up on the plates, it reduces the surface area of the plates, and there's less current going into the battery. But as I say, when it's on a vehicle, the vehicle's shaking, it's shaking the bubbles off. If you've got an old-fashioned charger which buzzes, that would put a better charge in a liquid car battery than one of these modern chargers. Now that's all I'm going to do on batteries, and I hope that simple explanation helps people. Don't mix and match batteries. If one goes faulty and it's either series or parallel, change them all. Not just the one that's faulty, because you'll create problems in the future. So thanks for watching this video. Please subscribe and like.